Let's prove property number 8 of theorem 10.2. Okay. Proof of property 8. And we're assuming that we already know everything from before. So in particular, we already know that if K bar is a subgroup of G bar, then the inverse image is a subgroup of G. So by 7, we already know that phi inverse of K bar is a subgroup of G. So the only thing that's left to show is that it's also normal. So phi inverse of K bar is normal. Now, how do you show something like that? How do you show that a subgroup is normal? We have theorem 9.1, and that was the normal subgroup test. And the normal subgroups test said that you have to show in this particular case that G, phi inverse of K bar, G inverse, is a subgroup of phi inverse of K bar for all G. So that's how the normal subgroup test works in this case. And then if we dig into this statement over here as a subset statement, how do you show that? Well, you take an element that's on the left-hand side. So that's going to be like a G, a K, and a G inverse. So this is going to be an element in there, actually, other way around. Oops. So that GK, G inverse is an element on the left-hand side, and then you show that it's also an element in the right-hand side. So you show that it's also an element on the right-hand side right there. And to dig one layer further down, how do you show that? Well, you look at phi of the element, and you show that that is an element in K bar. So that's the strategy of this proof. We take something arbitrary on the left-hand side, we look at its image, and if we can show that it's in K bar, then we've succeeded by using the normal subgroup test. Okay, so let's get going. So let's take any K in the pre-image or the inverse image of K bar and any G in G. Then what do we have? What does phi of this GK G inverse that we talked about look like? Well, since phi is a homomorphism, first of all, it's phi of G, phi of K, phi of G inverse. And then by one of our previous properties, theorem 10.1, that is phi of G, phi of K, and then the inverse of phi of G, the inverse of phi of G. So that is by theorem 10.1. But what about this element right here? So phi of G, that's an element in G bar. Phi of K, that's an element in K bar. And phi of G, inverse of that, is an element in G. So then, by using the normal subgroup test on K bar, we can conclude that this element that we are getting is in fact in K bar, since we know that K bar is normal. In G bar, using theorem 9.1 again, the normal subgroup test. All right, so we have shown that phi of G, K, G inverse is an element in K bar, but that tells us then that G, K, G inverse is an element in phi inverse of K bar, and that tells us that G, phi inverse of K bar, G inverse, is a subset of phi inverse of K bar, and that's what we wanted to show. So by the normal subgroup test, theorem 9.1, let me write theorem, we have that the inverse image of K bar is a normal subset of G.